seeing the rectangles.
Okay.
I know
So today what we're going to do is we're going to use rectangles and fit them in under our curve to calculate the area. And then tomorrow we're going to talk about trapezoids. Okay. And then eventually we will be able to find the exact area under the curve. So here are the 3 different ways we are going to approximate our area today. Okay, here is a curve. We're either going to take we're either going to take our rectangle and make the right side as tall as the curve and find the area of those rectangles. Or we're going to take our rectangles and put the left end to make the height of our rectangle on the curve. Or we're going to take the middle of the rectangle and make that the height from our curve. Do you think that looks like the best option?
Yeah.
Okay. Now I have something here and I don't remember what it is. I don't even know if it's going to work. Okay, so here are our left endpoints. Here are our right endpoints. Here are our midpoints. Now what's going to happen the more rectangles we get? We're going to be more accurate with more rectangles, correct? Now, sometimes we're going to get a number that's probably bigger than our area. Sometimes we're going to get a number that's probably smaller than our area. But hopefully we can get close. Okay? So you guys think middle is going to be the best?
Yeah.
Okay. Do you think it's going to depend on the curve?
Yeah.
Okay. Any curve you want me to type in here?
Some third rule.
You should do
To the third power, I mean, or something crazy. How about a square root one? A square root one. How about that? Or
long as
square.
Okay. So this one looks like it would approximate it a little bit better, right? What's the difference between the 2 graphs? Why was there more gaps in the other one?
Because it was vertical. Up? No.
Is it more?
Steep?
It's flat.
Steeper?
Yeah.
Right? Okay. Well, I don't know. This is just kind of fun to play around with. Okay. But you see the point. We're not going to get it exact, but we're going to get it close. And obviously, the more we have, the more accurate we're going to be. Now, if we have to calculate every single rectangle, the more we have, the more obnoxious our calculation is going to be, right? So the only point to do this is to make it bearable, at least for us, right? Okay. Fun stuff. So here's what we're going to do. The first thing we're going to need to do is figure out how many rectangles we need. Most of the time, well, I'm going to tell you how many rectangles we should approximate. Okay? You're going to be instructed, use this many rectangles. Okay? The more you have, the more obnoxious your calculation, so it's not going to be a giant number. Okay? Then you're going to decide if it's right, middle, or left. Okay? To make the height of your triangles. Excuse me, rectangles. Okay. Then we need the heights and the widths of each of our rectangles. Which one of those is going to be the same for all? The widths. The widths of our rectangles will be the same. how can we figure out how wide our rectangles are?
The subdivision,
Divide what?
divide how, total by how many rectangles.
Okay, so we're going to be given an interval. That's the only way we're going to be able to find an area is if we know what interval we're talking about. So we're going to take how long our interval is and we'll divide it by how many rectangles we want. Okay? The heights of our rectangles is going to depend on what? Right. And we are going to have to, the left, right, or midpoint is what's going to affect the heights of our rectangles. Okay? After we get each of our rectangles, then we can add them all. Okay. Sounds pretty easy, right? Okay. Now, we know that we're not going to get exact. We're going to either get a little bit more or a little bit less. Okay? Can you picture what it would look like to be under the approximation, and what would it look like to be over the approximation with our rectangles, with our picture?
Does it depend on the curvature?
Mm-hmm.
Yeah. Cool. Like talking about now.
Okay, look at these. Well, no. Here's left endpoints, and here's right endpoints. Which one is going to be an over approximation?
Right.
The green, right? Okay. What if our curve was decreasing?
Well, then the right one,
It's going to be opposite, correct? Okay. So if we have rectangles that are inscribed, which means they're all inside of our curve, we're going to have an under approximation. If our curve is decreasing, then these are the right endpoints that are under approximating. If our rectangles are circumscribed, which means they're outside of our curve, okay, then we get an over approximation. With this decreasing, it's the left endpoint giving us that. Obviously, if our function is increasing or decreasing, those under and over approximations are going to switch. Okay, so you guys can picture what the rectangles will look like, whether they're going to be mostly outside or mostly inside of your curve, and so you know whether it's an over and under approximation. Okay. What we're going to do, I'm going to give you a curve, and we're going to do all three approximations. Okay. Everyone ready?
Yeah, sure.
Okay. We have the curve y equals x squared, and I want to approximate the area under the curve from 0 to 1. Now, anytime we're talking about area under the curve, we're talking about from the curve to the x-axis. That's the area that we are talking about. Okay? So I'm going to go ahead and tell you that I want 4 rectangles. Okay? So how do we find how wide our rectangles are?
Divide 1 by 4.
Why 1?
Because that's how big the interval is.
Okay, our interval is 1 in length. Okay? It's nice because it's 0 to 1. If it doesn't start at 0, how would you find the length? Okay? You can take b minus a, right? And divide it by n. So each of our rectangles are going to be 1/4 in width. Okay. Let's go ahead and do a left endpoint approximation. So if we're talking about a left endpoint approximation, then the very first number in our interval, that's what we're going to plug in to get our height, right? So what's the height of our first rectangle? 0. Our first rectangle has height 0. Okay. Then we're going to use for our next rectangle. Okay, our next rectangle is 1/4 over, so we're going to have to use 1/4 to get the height. And how do we get the height? Plug 1/4 into your equation. That's going to give you your height, right? So this rectangle has a height of 1/16. Okay. Our next rectangle is going to have a height when x is 1/2. Right? So when we plug 1/2 in, what's our height? And then our fourth rectangle is going to have a height when x is 3/4. So our height is
Around 16.
crunch this in your calculator, but I want it as a fraction. Actually, I want it as both.
Fraction, I got 15, 30 seconds. Maybe.
I didn't have
I,
mine.
I,
Yeah, I got 7:30
I
seconds.
probably just didn't put parentheses. That's fine. Oh, that would be one.
And what kind of an approximation is this? Under. It is less than the actual area. Because we have some spaces that we don't have area for.
1/4 times 0 is
That is true.
Oops.
Okay. All right, let's talk about a right endpoint. Okay, so our rectangles are still going to have width of 1/4, but now our heights are going to change. Now, when I make this first rectangle, the right side of the rectangle is what the height is going to come from. So the height comes from when we plug in 1/4, right? So our area is going to be 1/4 times, well, what's the height? 1/16. Plus our next rectangle is going to come from when x is 1/2, because that's the right side of that rectangle. And so that has height 1/4, right? Our next rectangle, the height comes from the right side. What's the height of that one? 16. And then our fourth rectangle has height of 1. If it helps, okay, this is a nice example because the numbers are really nice. If on the right endpoints you want to start from the right, and plug in the very right number and then go down by your interval, you can do that. Okay? Whatever makes more sense in your head. Okay? So what is this approximation? Ooh, someone was ahead of the game.
Because Aaron already plugged it in for us. Got the decimal point. Oh, no, deleted it.
Okay. And this is an over approximation because we have these pieces of the triangle or the rectangles, I don't know, that are outside of the area that we actually want. Oh, now let's try midpoints. Why are you dreading midpoints?
Not ready. That's not fun.
It sounds fun. Okay. Our rectangles are 1/4 in length and width, right? So for this first rectangle from 0 to 1/4, we're going to get our height from the middle. And what's the middle of 0 to 1/4?
125.
1/8, right? Okay. So our area is going to come from we're still 1/4. What's the height of this rectangle? We plug in 1/8 to get it. So the height is 164. This rectangle between 1/4 and 1/2 gets its height from where x is 3/8. This rectangle gets its height from where x is 5/8. Do you see why this maybe isn't quite as enjoyable? And then this height comes from when x is 7/8. Why are you? Okay. You understand how we're getting it, right?
Yeah.
Okay. It's just fractions. Which is the same as 0.32812. Okay. Our actual area is 1/3. Which one was closest? Middle, like you guys thought, right? That's actually pretty darn close. Okay. Our rectangles are pretty small because they're only 1/4 in length. Width, whatever. Okay. Does anyone have any questions on how we're getting the height? Are we okay with the height? Okay. So let's do another example. I want the upper and lower sum of the area of 6 minus x squared from 0 to 2. Okay? If I am asking for we're going to go lower sum first. Lower sum would be what kind of rectangles if we have a decreasing function?
Right.
They're going to be right. If I put the right side of my, the right corner of my rectangles on the curve, we're going to be under the curve, right? Okay. So how wide are our rectangles? We have 4 rectangles from 0 to 2. They'd be 1/2. Okay, just to reiterate that, you're going to subtract your interval and divide it by the number of rectangles you want. All right. These have been nice because we started at 0. You might have some that go from like 1 to 5. All right. Okay, so we have 4 rectangles And these are, we said right endpoints? Okay. So the rectangle, do you guys want to start from the right side or are you okay starting from the left?
We're good.
Right
I
side.
can't speak for everyone.
Right side.
What?
I'd rather start from the right.
You want to start over here? Okay. So since we're using right endpoints, let's start from the right. So the very right is 2, right? So if we use 2, what's the height of that rectangle? It's 2? Oh. So 1/2 is the width times 2 is the height. Okay? Our next rectangle, these have width of 1/2, so comes from, it's going to stretch from 1 to 1.5, right? And when x is 3/2, where are we? Not a whole number,
It's 6 minus 9 fourths.
which is?
Who's got it? Who's gonna 15 fourths? Yeah, 16 fourths. Yeah.
Okay. Then we'll move 1/2 again to where our height is coming from when x is 1. And then our last one is going to come, the rectangles from 0 to 1/2. The height comes from when x is 1/2.
23, 23, 24.
Okay. 23/4.
Yeah,
Why did I write 24? I don't know.
I think I said 24. You got it. $419/48.
Reduce that. Wait, 419/48. Is not what I got. I get this. Okay. Somebody else can double check.
Yeah, 33
Okay. Yeah. This is good to talk about. Caleb probably had all of this written down correctly, but his calculator did not. He didn't punch it in his calculator correctly. Okay? If he did not have this written down and just gave me a wrong answer, would he get any credit?
No.
No, if he had this written down but typed it in wrong to get the wrong answer, would he get some credit?
Yeah.
Yes, he would, because he has the correct work. Please show your work. Okay. Let's do the upper sums, which means we're going to use what endpoint?
The left.
Left endpoint, right?
Yes.
Because left endpoints would make our rectangles bigger.
Yep.
All right. So from 0 to 1/2, we're going to use the height when x is 0. So that height would be
6.
from 1/2 to 1. We're going to use the height when x is 1/2. So that would be 23/4, right? What's nice is we already have some of these values, right? From 1 to 3/2, we're going to use the height when x is 1. And from 3/2 to 2, we're going to use the height when x is 3/2.
So the 15 fourths.
It must be. The actual is 28 thirds. All right, so let's look at your homework. On page 262, 23 to 30, they're asking for upper and lower sums. And they actually give you the picture with rectangles. Okay, that's nice. Now on 63 and 64, they ask you to approximate with the midpoint rule. What I'd like you to do for 63 and 64 is do all three. And to do all three for 63 and 64. Okay. You can draw a picture. It's not something that I am going to require you to do, but if it helps you get the right value to plug in, that is fine.